It gives me great pleasure to invite Mr. S. Gopakumar, President, NFE, Managing Director, Cape Electric, to give the overview of this event. A respectable dignitary is an electrical engineer, Managing Director of Cape Electric. He has more than 28 years of experience in electrical safety, lighting protection, EMI, EMC. He is a member in BIS and NBC as an electrical committee. He has published many articles in various magazines and published the book, The Missing Link, about electrical safety. He is also the program director of Vidyut Surakshit Bharat Abhiyan, a mass awareness program of electrical safety supported and participated by Bureau of Indian Standards, CEA, Indian Railways, ISRO, BHEL, and various state government electrical inspectorates. It is our privilege to hear you from you, sir.
Thank you very much. One moment, please. Let me connect my laptop. I have connected. They will check. So, good morning, ladies and gentlemen. Good morning to everybody. Next 2 days we are going to have lot of technical discussion. Normally 2 days program, first day, first half 100%, in the afternoon 80%. The last day, the second day, second half only 50%. Please don't take it in this way, because we are going to discuss a lot of technical subjects. Nothing about products or something like that. Only what is written in the NEC will be discussed these 2 days. So we are from NFE, National Federation of Engineers for Electrical Safety. Myself, along with Mr. Appavu, there is a background for making this kind of an association. At the end, I will tell you why we jumped into making a kind of an association. So 2 days we are going to discuss about NEC, National Electrical Code. This is published on 6th of January by Minister Piyush Goyal. That was 6th of June is the National Standards Day. We have been working in this NEC for almost now 6 years. The work started immediately after publication of the National Building Code in 2016. Actually, it came 2017. After that, we were working, and there were more than 50 meetings during this time. We were actively working on this code, and finally it is out. Now, why we are very much focused, or why we are giving more stress on NEC is very important. All of you knows the electrical safety situation in our nation. Lot of accidents are happening. Almost every day in newspaper you can see one or the other accident, something fatal, something not fatal, but unfortunately non-fatal is not in the news, so we really don't know. If we go to hospital and if we ask somebody, secret, did you experience any fire? Then they always say, yeah. Last week we had one month back we had one, but nothing happened because we could suppress it or we could manage it. So this means that only few are coming out in the media, or only few are known to us. A lot of accidents are also happening. In 2016, when we were starting the work of NEC, there was a workshop which is arranged by CEA, Central Electricity Authority. A Japanese delegation, one gentleman came from Japan who was in the standards body or some association there. He made a presentation about the global scenario. So I took these pictures from his presentation. According to him, approximately 723 people are getting killed due to electrocution out of 100 million population per year. 723 out of 100 million population per year. This is the average of India. And you can look at the graph. The best is Japan, about 12. And in Germany, it's something about 87. But please note that in our nation, all the accidents are not recorded. Only few are recorded, or it goes through the government mechanism, the electrical inspectorate record it, it goes to the Central Electricity Authority, then they the NCRB, they published the data. This data is from NCRB. This means a lot of accidents are still not recorded. We don't know the actual scenario, actual situation. In the same, but what we should understand is we are leading in this particular case. Number of accidents are much more than other leading nations. The same presentation, Mr. Takashi Honda, he made a study and he published this study, the second slide on the right side. They made a kind of a survey about the electrical safety scenario globally in G20 nations. It's like a survey. They asked about 30 questions and with hundreds of people. Finally, we got the least mark, 16%. Our reliability is 16%. In comparison, you can see what is the situation, for example, in South Korea, 81%. So here also we have the least. In Japan, during 1950s, the number of deaths were approximately 600 per 100 million population per year, but during these years they reduced, even though the usage of electricity went into a very high level, they tried to manage, or they made a good system. As a result, the number of accidents had reduced a lot. I am sure some of you must have seen this video, which has happened in a hospital. You are seeing an ICU. Inside the ICU, you know, the nurses, the medical staff, they found some problem and they were running. Please note that so many patients are connected to biomedical equipment. A lot of, and now they are trying to make this gentleman out. You can see smoke from the equipment. It's nothing but a ventilator, which is a life-saving equipment for that particular patient. And after some time, it catches fire. So now you can see what is going on. Within 90 seconds, the whole room was full of smoke. And this fire ignited from the particular ventilator, and you can also look at the condition of the patients, those who are in and around. Luckily, in this particular case, nothing happened. No one was injured, because the nurses, the staffs could take the patients out of the room. After this incident, you know, during COVID time, there were several accidents. Several accidents happened, especially in hospital. During 2019 May, there was a fatal accident in Surat, a tuition center. On the steps, it was on the second floor or third, it's in the third floor. On the staircase, tire, you know, vehicle tires were kept. The air conditioner outdoor unit was also unfortunately near to that, and it caught fire. 17 children lost their life, and few tens lost their, you know, they were jumping from the third floor to the ground floor, and few of them lost their, you know, they broken their leg, hand and all. After this incident, this was in, I think, May or June 2019. After this incident, I was asked to go and make a survey. But unfortunately, you know, after a fire, nothing is there to survey, because all things already burned. After this survey, in the meeting, there was one of the Gujarat state minister was there. Then he was asking me, where are you from? I am from Tamil Nadu. Then what are you doing here? I told I am in the BIS committee. So I am just trying to find out, or trying to support the electrical inspectorate and other departments involved or investigating this particular case. Then he asked, okay, this air conditioner got fire, then what you people are doing? You have the standard, why don't you take initiative to implement the standard? Then I told, at the moment, sir, the standards are considered as a volunteer, or, you know, it's recommendation, it's not mandatory. So if it is not made mandatory, no one will follow. As a result, there are books, there are standards, but nobody follows it. Then we spoke about awareness, and one of the questions which he asked me is, because I spoke to him like a complaint, I told that no, the awareness is too less. Then he asked me, then why don't you people take initiative to educate the market? So then he was asking me 2-3 questions, and after that I slowly started thinking of, you know, taking some kind of classes. Anyway, and actually the ignition of this NFE started from there. Then during the same time, after the first COVID fire, I'm sure you are aware that the Supreme Court took a suo motu case against the state government. Myself and Appaus had become volunteer in this particular case. We volunteered ourselves as experts who can guide the fire, the court for settling this case. And finally, in one of the hearing, court, we could explain the problems to the court, and court, we got some, like this, some underground works were also going on. Now, basically, most of these fire accidents, if you look at the report of the fire accidents, about 80% of the fire accidents, the reports say it is due to overload. As an electrical engineer, electrical engineers should not accept this, because for overload protection, we have so many protective devices, and what these devices are doing. In case of overload, the device should trip. This was one of the, but we never think why the protective device is not tripping. We always try to put, the size the protective device much more than what is required. This is one of the reasons. Anyway, 2 days we are going to discuss this particular subject. All of you are aware that the mandatory requirement is the CEA regulation. Mr. Uma Maheshwar is on the way. We will have a presentation from him. Our regulation 2010, of course, the new regulation is about to come. It's in printing. Probably in next 10 days it is coming out. The new regulation is called as the Central Electricity Authority Measures Relating to Safety and Electric Supply 2023. And this regulation has made NEC and NBC as mandatory requirement. Earlier it was NEC may be followed. The word has been changed to NEC shall be followed. So in standards making, in standards, these wordings may, shall are very important. Now the word is shall, that means NEC and NBC are becoming mandatory. So legally it's required to follow. Most of the time, if we look at investigate a failure or an accident, most of the time compliance to these standards and regulations, I'm sure you know very well the situation. Mostly the requirements are also not very well known. Lot of misinterpretations, maintenance and negligence. Actually, electricity installations within the house, most of the time we try to put some beautiful things. Whether these beautiful things will work or not, most of the time we are not bothered. We don't do a checking. For example, IS 732, 1989 has included this code. IS 732 is called as Code of Practice of Wiring. Means it's a code, you are supposed to follow it. It has included testing in the standard in 1989. There are 10 testings. Even today we don't do. There is one test called as fault loop impedance. If we do that particular test alone, we could have found out whether the MCB is capable of tripping or not, but we don't do. This is the reason for the maintenance part which I meant is this one. Also, we have a habit of following anybody's standard. Somebody from NFPA will come, I have American standard, then we say, okay, let me construct my electrical system with the NFPA. Somebody follow British standard, somebody follow German standard and European standard. There was no awareness even to the international standard. So what we decided is we will try to first educate the whole engineers that what do we mean by this international standard. International, there are only 3 international standards, ISO, IEC, ITU. ISO, you know the subjects. IEC for international electrotechnical subjects. ITU is for telecommunication subject. The India representative of ITU is TEC, Telecommunication Engineering Center. Otherwise, ISO and IEC is handled in India by BIS. These are the only international standards. Now, the code, if you read, the code says if there is no Indian standard available, you can refer international standard. International standard doesn't mean you refer British standard or Bangladesh standard or Pakistan standard. They are international that we generally speak. With respect to standard, these 3 are the international standards. But in practical, if you look at most of our tender requirements, the designers are trying to put so many requirements, something from Britain, something from Germany, something from UK, and actually we create a mess out of the electrical installation. For example, confusions like earthing, grounding, somebody says earthing, somebody says grounding, somebody they says RCD, RCCB, somebody says ground fault, interrupter. All these confusions come. Now, globally, all over the world, the IEC 60364, it's a series of standards. The global wiring rules are made based on this IEC 60364. In America, the standards are accepted as National Electrical Code of America. In Britain, the same document, word by word same, is called as BS 7671 Code of Practice of Wiring, and VDE 100, this is the German standard. In India, the same standard has been adopted as IS 732. The first, fourth edition came in 2019, which talks about design, erection and testing of an electrical installation. The NEC, which is published last January, has added few more information. It contains the basic information of IS 732 plus requirements regarding generators, transformers, outdoor installations, solar PV, lightning protection, explosive areas. All these jobs or all these subjects related to electrical engineering are also added into the NEC 2023 with a lot of modifications. Of course, we try to make some simplified wording. Earlier, you know, sometimes once when you read a standard, it's quite complicated to understand because the wording, sentences, you know, it starts somewhere and it ends. So Mr. Uma Maheshwar is here. Why don't you come? Welcome, Mr. Uma Maheshwar. Mr. Uma Maheshwar is the Superintending Engineer of Central Electricity Authority, Inspectorate Wing. I'm sure you are aware that every state has got an Inspectorate Wing. Similarly, central government also has got an Inspectorate Wing. So, Mr. Rao is the Superintending Engineer or head of Region South. Now, coming back to my presentation, in electrical installation, we have so many electrical devices and appliances, such as if you look at the industrial or a large commercial installation, starting from the high voltage side, then we have the transformers, DGs, UPS, solar PV, then wires, wiring system, installation system, support system, then we have panels and protective devices, meters, automation, then finally we have the current using equipment. One question people always ask is, can I select some motor based on NEC or can I select some switchgear based on NEC? Actually, NEC is not a product standard. You cannot find out any details of a product from the standard. What product in the sense? The quality requirement of a product, the testing requirements of a product. These are not included in the code of practice, NEC. Then what is NEC? NEC is a product or NEC is a code which explains about selection, erection, verification of an installation mainly focused on safety. Selection, erection and verification. Selection and erection, this is mostly the job which is much involved to a designer. Erection and verification is again involved with the contractor. Verification is a new subject. As I told, 1989 also it's included, but nobody bothered. But this time, since NEC is made mandatory, the electrical inspectorate will be forced to ask you the question. You submit me the test report as per National Electrical Code for your building. And with the current design, if you try to test, you can be sure that you will get the red seal. Now, the installation is classified into normal installation. That means everything related to a normal circumstance, normal electrical installation, and special installation. Special installations are additional safety measures required for places such as bathrooms, medical location, office complexes, street lights, outdoor installation and so on. So normal installation is covered in part 1 from section 1 to 22. There are 22 sections in the part 1. Special installations are covered in part 3, again section 1 to 22. Each of these section covers one particular subject. For example, part 3, section 9 talks about medical locations. It also covers subjects such as the sources, DG, UPS, solar PV. in various parts, also covers power quality, energy conservation, lightning protection. Please note that power quality for the installation, not for a particular equipment. For example, energy conservation of an installation. Normally, energy conservation, we always look at an equipment which is saving power. Either use a device which is conserving energy or limit its usage so that energy is conserved. Whereas what is talking in the NEC is about, for example, Barry Center method. You have a large industry. You divide the industry into various zones. Find out the area where you are going to utilize more energy. Then you design the electrical installation in such a way that the power loss in the circuits or power loss in the distribution or power loss within the installation is reduced. That is what is included. Now we must also understand that electrical installation nowadays also require functionality, because more and more we are dependent on electronics. You know very well, BMS and automation. NEC is not a document for functionality. NEC is a document for safety. Don't try to think that, if everything based on NEC is done, we are done. It is not like that. Everything related to safety is done if you follow NEC. Functionality, there are some additional standards as well. Lot of time, once when we make these training programs, people ask, why do you have so many documents, electricity regulation, code of practice for earthing, wiring, lighting, and so many documents are there. Why don't you make everything together in one document? Actually, in electrical engineering, this is not possible, because we are talking about electrical engineering. For example, lighting alone, that is a big subject. Harmonics, that is another big subject. EMI, EMC, power quality, another subject. Power quality alone, there are about 90 plus standards. So it's very difficult to make all the subjects into one, totally enclosed in one book. Impossible. Whereas in NEC, the advantage of NEC is, if you wanted to know anything related to safety, you take NEC, because it talks what you should do in a transformer, what you should do in the panel board, how to select the cables, what are the conditions you should fulfill. Anyway, we discuss about this in the next 2 days, or today and tomorrow. And during this time of making the NEC, we were trying to make an association, because all of you knows very well that there is no association or a body exclusively for electrical engineers. Of course, there are associations for the contractors or for each and every, some of the areas there are some specialized agencies. But for the whole electrical engineers, there is no agency who is involved. So we thought of founding NFE, National Federation of Engineers for Electrical Safety. Our vision is to make a very safe, electrically safe Bharat. And we already started doing a lot of activities. I request each of the electrical engineers to join NFE. We are not going to talk about anything related to products or something like that. We are going to talk what is the technology, the basic fundamentals of electrical engineering. You get a lot of information from NFE. I go through the divisions, then you will be able to understand a little bit more. In the website, you please go to the website. There is a place where you can join and you can pay by card. There is a small fee, about 1,500 plus taxes. Then you should join and become member. And if you are a member, all the programs of our awareness programs, you can participate free of cost. The functions, what we are trying to do is create awareness about the electrical safety, increase the skill of people, because skill development is a major area to be focused. Let me skip this one. Okay, the first one is training, development of knowledge and skill for electrical engineers. Second, product development. Product development, what we are trying to do is, most of the time, if we look at what is written on an international standard for a product and what is sold in our market, there is big gap. In the sense, say for example, LED lights. In Europe or in America, LED lights with more than certain percentage of harmonics, you cannot sell in the market. For example, 8%, you cannot sell it because it's banned. This the requirement. Whereas if you look at India, if you buy 10 LED lights, put it in your house and check the harmonics, probably it is 35–40%. This is even true for even the best brands in the market. Why? Because this information is missing. The engineers are not really putting their mind into it. So NFE will get the information from international bodies. We will try to find out the best product requirements. We will pass it on to the engineers, those who are designing these products, help them in doing testing of the product. As a result, we need to have high quality products. It is the time we should do. The third objective of the NFE is a quality and accreditation system. Actually, the consultants, those who are advising us, they told me not to talk about quality and accreditation, because accreditation, we are trying to make a scheme for certification of engineers. Certification, for example, at the moment, if we ask a question, who is the electrical consultant or who is an electrical inspector, there is no qualification criteria available. We are trying to create a scheme based on the ISO standards. So, but this is not a small job, it's a big job. For example, in our scheme, there will be an answer to the question, who is an safety auditor? So he is a person who is accredited as per or certified as per the scheme based on the personal certification scheme of ISO 17024. So we already started the meeting. We have the support of Balakrishnan sir also. We have made a committee and we started the documentation. Probably in next 3–4 months, we will be able to publish the first document for public comments. Then our fourth agenda is to support the standards and regulation. Of course, lot of missing gaps are there. Some standards are upgraded, some standards are even 1960s, because nobody demand an upgradation. There are electrical engineering standards 1970s, 1980s, 70s, 80s is also okay, 1960s. For example, one of the standard which we have taken up for upgradation is for the public overhead line, the post and how to connect the lines and all. This standard is 1962, used even today. Nobody demands, as a result, nobody tried to change it. This situation should change. We had started supporting organizations. We had our first MOU with AHPI, Association of Healthcare Providers India. It's an association of 20,000 hospitals in the country, including Apollo, SRM, and almost all the big Ramachandra, all the big hospitals in Chennai. AHPI is located in Delhi. They have 20,000 members. They are finding big problem in having engineers, those who, biomedical or electrical engineers, those who are knowledgeable about the total system. There is a big gap. Now we have taken up this, with this MOU, we have to train almost around, close to 10–12,000 engineers, those who are working in hospitals and biomedical locations, about the new standards and most modern international practices. So this is exclusively for the AHPI member hospitals. So, and these member hospitals, the engineers working in those member hospitals, they will carry out audits, safety audits in their respective hospitals. We also signed the MOU with the Institution of Fire Engineers India to train their members. Their members are mostly fire experts. We have to train them for electrical safety. We also, MOUs with several organizations are under discussion. Please note that NFE is registered only 2 or 3 months back. Within this short time, we have close to 300 members. We expect to cross probably 1,000 by June, July. I hope this is possible. If all of you can support, it is not only a benefit of one person, it is for the benefit of all the electrical engineers. I request you to become member and let us grow together with respect to safety and our knowledge and our skills. Thank you very much.
Thank you, sir, for creating awareness and stressing on the alarming need for electrical safety and explaining the context of our meeting.